My greatest accomplishment is my tweets are my own. Yes, thank you. So thank you very much, Inbar. And yes, we're going to talk about making a few steps of progress today. I think this is important. You know, we spent a lot of time talking about the far future. Just before I walked in, one of the staff was, I was asking one of the folks who's working the event. I said, what do you think of this event so far? She said, it's good, but are we all going to become machines? Is that what's going to happen? And I said, listen, I'll be worried about becoming a machine when my computer can print to my printer. That's going to be a time when I can really be worried about that. Yesterday, Dawn, I thought, did a great job of kicking off as our first guest speaker of the conference. And at the beginning, he talked about, I think he took himself back 15 years to talking to his friend who was connecting the sprinklers to the fence and so on. And that kind of took me back because I know I've been doing that for 15, 20 years and doing, kind of wasting time on the weekends, ignoring my chores, wiring up my house to be, frankly, less useful than it probably was before. A few weeks ago, my wife was cursing at Alexa as she was trying to describe which lights to turn on and off. If anyone is trying to do that, it's kind of a pain in the butt. So I'm sure if there's anyone from Amazon here, we need to really improve that. It could make our lives a lot better. Almost as good as my fridge playing me music, which would be a real problem for me, by the way. I don't want that. So, what we did want to talk about today is making progress. And, we've been on this mission for a long time, and we've been sort of painting the vision of the future and then taking a few steps towards it, and painting the vision of the future and then taking a few steps. So we're going to talk about a few steps, and we're taking more and more steps, and these are really starting to accelerate. And I hope that you see that today because we're really excited. We have an announcement today about a new product coming, a new platform that we are launching, and I think you'll see that we're really starting to accelerate the progress with our customers and with our partners. So let's dive right into that. Now, Inbar shared this stat, and of course I think it's been quoted in the press. It was probably well crafted to be generate a lot of headlines. About 25% of projects, or 6%, being successful, which as a technologist I thought, hey, that sounds pretty good actually. I don't know if that's a bad number or a good number. But the reality is that probably that number is going up. That as more customers get involved and as more technology is being deployed, and as all of us in the technology industry are improving the platforms, our customers are having more and more success. So the main point is, let's see that number next year and see if it's going in the right direction. Are we improving the success that our customers are having? The survey that we did, very briefly, I thought was very insightful when it talked about the top 2 reasons, when you guys all sort of fed back the top 2 reasons about talent and complexity. And I think these, frankly, go hand in hand. I think that what we are seeing in this technology transformation is that, the other side of not having enough talent is, should you need the talent? Or is what you're dealing with too much complexity in the first place? So what's the real root cause of that? Well, clearly I think we're going to need more talent. We also could do a better job at simplifying the platforms and simplifying the solutions. Now, our team has been out. They love these 2 that came back because they've been out, and when we've been out, with our customers and with our partners for a long time, and we've been talking to them, especially over the last year, making a lot of progress and sort of understanding what's underneath the covers here. And the way I think about sort of the root of this is the coming together of these 2 worlds, the world of bits and the world of atoms. And one of our staff, our CTO, I was talking to him the other day, Jim. What Jim told me is, he said, what I see time and time and time again when I'm in front of customers is that you bring technologists to talk to folks who are sort of sitting in the real world, on factory floors or out in the field, and they're fundamentally come from very different places. That the lingo is different, the backgrounds are different, the care-abouts are different. We go in and talk about fog computing, this and that, and microservices. Customers are like, I got to go from 94% operational equipment efficiency to 95%. And by the way, if the factory goes down for an hour, I'm getting fired. So microservices are great, but what's that going to do for me to help me improve my business now, here, today? And I know that we've made a lot of progress on this front. We've been really thinking about this. But I think this is sort of underlying, in many ways, some of the struggles that we see. And I could sort of give you a simple example of this. For a lot of years, computing, coming out of Silicon Valley and sort of the tech industry in general, has kind of gone with this very simplified, almost canonical model, which is connect the stuff, shoot it over the net, put it in the cloud, build your apps, and do analytics. And this is kind of the answer to every problem, it seems like. And that's the direction of the tech industry in general. But as we take that relatively simplified model to our customers, what we're hearing is that the problems of the real world really mean that that simplified answer doesn't solve many of the world's problems, many of the real problems we find. Problems like security, reliability. Again, you can't go down for an hour or two, or somebody cuts a fiber line down the road. Who cares? I can't have my factory floor go down. I can't have cars start to crash because, some clouds rolled in. That's not going to work for us. So reliability, scalability, privacy, all of these real-world concerns are what we have to acknowledge and deal with in the technology, again, to take a few steps forward. So unlocking that and letting customers take a few steps forward. So that's kind of one example of the delta between these two worlds. Now, Cisco's got a foot in both worlds, as many of you do. And so we see the possibilities of technology, but we also see the realities. We are out down in the mines with our customers. We're out in oil fields, and we're on factory floors, and we're all over these environments, and we're seeing what's really happening, and we're seeing what it really takes to be successful. And what we've recognized is that we need to bring a set of technologies to customers with our partners. This is an industry-wide ecosystem effort to recognize the realities of the real world, but also sort of realize the potentials that some of these technologies can bring. And most importantly, make a few steps of progress. That's what I want. Make a few steps of progress. And so that's what we've done. We have built a technology platform to start making a few steps of progress with our customers. And we're announcing that today. And it's called Cisco's IoT Operations Platform. And I'm going to walk you through it, and I'm going to give you a real-world example. I'm going to demonstrate it. I'm going to show you the real code. No Flash or PowerPoint. We're going to show you the product. We're going to show you the console. We're going to demonstrate it in the real world, and hopefully it works. We'll see. So what is it? What is Cisco's IoT Operations Platform? It's an integrated hardware and software platform that allows you to connect, operate, and secure the end-to-end IoT system. That's what our platform is. Now, it's not delivered by us alone. It comes together with partners and the industry, but fundamentally, that's what it is. So we've figured out where we play, how we play, and I'm going to show you this technology platform. But we've taken our hardware and software and integrated it and wrapped it in services and security, and we're delivering that to customers. And so it's in early field trials now. We intend to launch it in the next couple of months. And it's most exciting is it's a very powerful platform for our partners to build on. And we've been talking to many of you over the last couple of days, and I think you're equally excited. So we haven't been working on this alone. Over the last few years, as we've sort of talked about what the potentials are and where the technology could go with fog computing and what does Cisco do with routers and switches and our future technologies and security and so on, we've had some great partners that have been helping us on this journey. One of them is sitting right here in the front row. Thank you very much. Harriet Green, who you're going to hear from later today at IBM. And they've been making great progress with their customers and some of our joint customers. And so that partnership is going really well, and they've been a big part of helping us get to where we are today. You're also today going to hear from another one of our partners, and that's Jason Zander at IBM, who runs Azure. We've made great progress with them, too. And so we're going to talk about how we're extending our partnership with Azure as a part of this platform in natively integrating Azure and Cisco's IoT Operations Platform. Very, very important for customers. I think a lot of the folks that I talk to are actually making real substantial progress with Azure already. And so tying together our hardware and our software with their cloud platform is like chocolate and peanut butter. It goes really good together. So that's the progress that we've made, and I think now we can a couple of our partners, I want to double-click now. I think you're going to hear from one other partner, which is Rockwell, so thank you. We've been doing great work with Rockwell all around the world with these platforms as well. Now, let me now double-click on what is Cisco's IoT platform, and I take you through the software components mainly. So we're going to start out with the three big pillars of technology that we're bringing together in this platform. The first one is connectivity management. And so it sort of makes sense to start with connectivity because that's kind of where everything begins. And our networks today, IT and OT networks, public and private networks, have been connecting devices for lots and lots and lots of years. So what's a connectivity platform all about? Well, a connectivity platform, or a connection management platform, as you see on the left-hand side here, is all about doing that at scale. So while we've been building networks out for years that connect computers and now our smartphones to the network, those are mostly devices that are attached to humans. And so they have an inherited sort of scale limiter, which is there's only so many humans on Earth. And so most of those systems tend to be pretty manual. Well, over the last few years, we've made a lot of progress with Jasper. So Jasper has joined us, and Jasper has learned that in order to really scale that up, you have to build a very, very robust system that's completely automated, with APIs and analytics built in so that you can, if you're deploying devices that aren't attached to humans, that you can manage those connections simply and easily in an automated way. No humans involved at all. So we're taking the learnings that we've had with Jasper and we're applying that. Where Jasper got started was the public operators and the mobile networks. We're extending those learnings out to the connectivity management, to private networks, IT and OT networks, so that you can have a single pane of glass to manage all of your thing connections end to end. And it turns out that's quite a hard problem, and so that's the first part of our IoT Ops platform, connection management. The next part is fog computing, and so fog computing is something that we've all talked about for a long time. For those of you who are not familiar, let me just recap the concept of this. A few years ago, Cisco, I think, and others in the industry recognized that the future of this sort of coming wave of things on the internet was going to require a fundamentally different model than what we had used in the past from a computing perspective. If you look at over the last 30 years, at least since I've been working, we've oscillated between centralized computing, even before my time, in the mainframe era. Then we moved to distributed computing in the PC era, and then we moved back now to centralized computing in the cloud era. But as we look forward to the scale of IoT, what we see is that neither of those is really going to work. Centralized isn't going to work for a whole bunch of reasons, and distributed all by itself also doesn't work for a whole bunch of reasons. We think that the answer is both. We think the answer is convergence of compute and network that is distributed throughout the entire network. In other words, taking what were formerly dumb pipes connecting systems and making those pipes smart, allowing you to put compute anywhere, from central all the way out to the edge. Very, very important for solving some of these problems of reliability and scale and so on. We're going to show you a simple example of this. And so that was sort of the origination of fog computing. And since we started talking about that a few years ago, many of the sort of experts and sort of the smartest folks in the industry have jumped on board, right? Whether it's AWS with their Greengrass offer, Azure IoT Edge, even the cloudiest of cloud vendors have recognized that a simple model of all cloud or all prem is not going to work, and we actually need a combination of both. And so a lot of folks have jumped on board with this idea of fog computing. And now we're starting to make real progress, and this is the good news, that we've really taken forward steps, and we're going to demonstrate it to you. And so what does it do for customers? Well, it allows you to achieve the benefits of reliability and scale by leveraging the power of the network. And now that we've essentially opened the networking platform to enable computing in the network. And we'll show you what does that do. It's really, really cool. Now, as we've started to deploy fog computing, we've been doing this actually for a few years, kind of silently in the background. We have learned that what customers needed was more than that. Again, they needed something that was simple. They don't have the experts necessarily in all cases to deal with the sort of low-level capabilities that we can bring to them. And they said, we need something simple that doesn't require coding. And we need to think about how we can move data on the network. So it's great if we can enable all this stuff, but how do we move data around the network? And so the learnings that sort of the first two technologies have brought to us allowed us to think about introducing a third new sort of key technology to this picture, and that's data delivery. And this is a simple concept, actually, but it's going to take a little bit of explaining. And I'm going to take you back to the beginning of time. And the beginning of time from a networking perspective. In the beginning of time, we had something called the end-to-end principle, simple concept. System A talks over a pipe to system B. They both know about each other. They've got addresses, they've got names, and system A says, connect me to system B. It's like Telnet or FTP, very simple, original internet sort of foundations here. What we've recognized is that this simple model is actually breaking in the IoT, because when you deploy devices, often there is no system B. If A is your thing, okay, it could be a sensor on an oil well, it could be a robot arm, it could be a car, we don't know in advance what system B is. So system B is going away, and there's, based on the customer's environment in real time, there's a whole bunch of different places I might want to take the data on system A and move that to other places in the network. And so if we don't know a priori where the data needs to go, then what do? The answer is we have to build intelligence into the pipes, and we have to allow customers or partners to configure that in real time and say, pull the data from the thing or from the source and move it to multiple different destinations depending on business logic and business conditions. That's what our data platform is all about. We've built, and it's actually built on fog computing. So these pipes have to be smart. The underpinnings of fog computing were required for us to be able to do this. And we built a product on fog computing that's very, very compelling and is actually solving a lot of our customers' needs. So what they're doing is they're using this technology to define the data at the edge, extract it from the thing, apply a simple set of rules that require no coding. So we go back to our expertise problem. You know, if I go into most of my customers and ask them to start writing microservices or containers, you know, they might have a few folks that know how to do that, but, you know, and they might know how to do it in a POC or in the lab. But when it goes into production, we don't want engineers being in the mix, needed to keep these systems in production operating on a regular basis. We need operators and the existing folks who know how to run these systems running them. So we had to build a system that required no coding whatsoever, but was dynamic enough to implement simple rules. And what we've discovered, back to this idea of simple steps, we've discovered that we could make a lot of progress by doing some really simple things. By providing some simple rules in the network, some ability to kind of configure without coding, but drag and drop, if then that kind of capabilities, many customers' use cases could actually be solved, or at least get them started on the path. Let's get started on that path, and so that's what we've done. So we've, of course, if what you need is more than what we've built in, which is often going to be the case, go ahead and get that if you like. We can take that data and we can still push it off to the cloud. We can still do deep analytics, Watson and Azure, or all over the place. But we can do a lot, actually, without writing any code whatsoever. So that's pretty exciting. Our customers have been using it. We've been using it in a whole bunch of different industries. And they've been making real progress, and we're going to show that to you. So I think we should just do that. So those are the three parts: connection management, fog computing, and data delivery. Now, Chuck yesterday talked about something real important to this platform, and that's security. So yesterday we had our announcement of our IoT Threat Defense offer. And what's important about the IoT Threat Defense offer as it comes to this platform is it's built into every layer of the platform. So this isn't some sort of separate product that you get and it's on the side. It's built into every single part of the fabric, and it's wrapped in services. So it's really a great offer, and you're going to hear more about that coming up. But we're really thinking a lot about security. You know, when we saw Mirai come along and you know, that attack on a million cameras, I mean, absolutely could have been prevented. And we think that we can make real progress by using all the parts of our stack to improve that. And the final piece of this platform is about communications. So for a long time, we've been thinking about the collaborative opportunities in many customers' environments. At some point, when you automate all this stuff, eventually, you may want to talk to a human. You may want to bring that human into the loop. And to do that, we needed a programmable platform to allow machines to talk to humans. And it turns out that that's easier said than done. You know, if you want to, my fridge is going to send me an SMS, it needs to have a nice, simple, REST-based API to be able to send SMS messages. Tell me that I'm running out of milk or that the pizza's getting old, I guess. And we built that, and it's not just SMS, but it's SMS, text messaging, using a variety of different platforms, even voice and video, one-to-one and multi-party. And so it's not only machines talking to humans, it's then the humans being able to communicate back to the machines or humans to humans. So we're kind of completing this loop, which is really important in operational environments. You want to have this platform. We've been seeing great progress with Rockwell, actually, as we've been out in front of some of our mutual customers, just doing simple stuff, connecting the operators on the factory floor. And so I think that's very, very exciting. So these are the 5 parts of the platform, okay? And they're coming together, finally, and we're wrapping all of it in services. As we take it out to the customer, we realize what you want is you want total integration. Hardware, software, all these components and bits and pieces, all integrated together and then supported. One place to call if something goes wrong and so on. James Mobley is here from our services group. He's been talking about how we're wrapping all of this in services to take to our customers. So between all of those elements, we're able to make real progress, and customers like this offer. So I think we should just jump right into it. I'm going to take you now, and we're going to do a demo. What you see on the screen behind me are the rolling hills of Tennessee. Anyone been to Tennessee before? Yeah, woo, Tennessee. Beautiful place. It's beautiful, but it can be dangerous. The fog rolls in, pretty swiftly in Tennessee. In fact, many, many years ago, they had a huge pileup of cars because of the fact that the fog had come in so densely and so thickly on the roads there. And they've been struggling to work through how to solve that problem using technology and people for a really, really long time. Turns out it's a very complex problem, and they haven't actually had a lot of success making real progress until recently. And we were able to take our technology and bring it to the Department of Transportation to make real, substantial progress using the platform that I just talked about. So very exciting. So we actually brought from Tennessee the gear from the roadway. You can see it over here. We can get the lights up a little bit. And you can see the gear from the roadway that we brought along. And we're going to show you how we've tied that together using this platform. And to help me show you that, I want to invite onto the stage here Mark Nellinger, who's our systems engineer. Mark, come on up. Here we go. How are you?
Thank you.
Everybody, welcome,
morning,
Mark.
Rowan.
Fresh in from Tennessee, you brought the gear here with you.
Absolutely.
So thank you very much. So let me just give you guys, Mark's been on this for how long now?
About a year.
About a year. So you've been taking the IoTWF platform, and you've brought that to the Department of Transportation. So I think it would be great if you could just talk about, when you started the engagement a year ago, talk about the problem that they were having with the existing systems.
So with the Tennessee, we've got a varied landscape, and the fog moves in very, very quickly. And so the Department of Transportation is really focused on public safety, saving lives out there. And as that traffic moves through, if that fog rolls in quickly, their sensors were disparate systems from their signs and their gates. And so they really had a hard time with the operators sitting there who are currently managing incidents where we have accidents on the roadways and people with flat tires and things of that nature. And they were doing all this work at the same time, and yet they were trying to monitor weather as it rolled in. And then if they got an event, they would have to go to 3 different systems in order to actuate gates or to change message boards.
So they were swivel chairing.
That's exactly right. And it just wasn't efficient. It was very, very, very manual.
And they've been working on this for how long?
25 years almost, really how to solve it. So they've been putting in millions of dollars in sensors, in gates, in signs. They've really been doing everything they possibly could to tie this together, and it's still a manual process.
Interesting. So let's actually show what you brought here.
Absolutely.
What are these sensors and how do they work?
So we've got our humidity and wind direction and our temperature, and then we've got visibility sensors that are out on the roadway. And these can detect even small smoke particles or fog or any type of weather changes. And
that's this big one here?
That's exactly right. And as a legacy sensor, it goes to a controller and then is serial-based from there.
Let's show it. Let's
Absolutely.
show the wires all connected in here. Here they are.
So we've got our controller. And so with the serial connection coming in, and it's not very reliable, they're pulling from a central server out to these remote sites. Some of them are very remote. And it hasn't been reliable or effective.
Okay, so they get disconnections, they get polling problems, they get the swivel chair problems, all of that. So that's the sensor side of things. They've got the box on the roadway, and then they've got you brought here like a kind of a mock-up, I guess you could say,
That's right.
that doesn't look like it would stop much, to be honest, but
Yeah.
a gate and a sign. So this
Correct.
would represent that part of the picture.
That's exactly right. These are large signs over the interstate, and these are actually capable of closing on-ramps.
Okay, gotcha. And so they use this combination of sensors and actuators essentially, plus human operators in the middle, to solve this problem.
That's right.
But it hasn't been working well.
Doesn't work well at all. If they're working a really intense accident, an operator will never even notice that fog has rolled in.
Okay.
And then it's a manual, it's a manual dispatch in order to get the gates closed.
So what Mark has done, and I think we should go show it. So let's go over on
Great.
stage and we'll show the software working in action. Then we'll come over and prove that the software actually works.
That's right.
So you were able to take this is we're looking at here on the screen is the console. So why don't you explain the Data Connect platform and how this is connected to that stuff?
Absolutely. So on the left side, we've got our inputs. We've got our light level meter, which is just a visibility, telling if it's day or night. We've got our visibility, which is clear or foggy, and that's based on thresholds that the DOT has set per each region. We've got a large stream of a live stream of data that's coming through that we can see is coming right from the box.
So that is live. That's 136 feet of visibility.
That's
right
correct.
now. Okay.
That's correct. And so these are our inputs on the left. On the orange, we've got our logic, and currently we've got it set up so you could see that there are 3 different conditions that we're going to meet. If it's daytime and it's clear, we're going to have a default message on the message boards. If it's daytime and foggy, we'll just warn the drivers. We won't necessarily stop them from being able to drive the roadway. But if it's foggy and at night, we actually do want to articulate the gate, and we want to close the roads.
So simple data modeling, visual, no coding.
That's right.
And this is all essentially running on the network. So we've modeled the data as discrete from the underlying physical topology, which is what Chuck talked about yesterday. He talked about separating the data model and the data flows from the physical topology. What you might expect to see from Cisco, and you've been with Cisco for 15 years or so?
10 years, yeah.
10, okay. Hopefully 15 if this demo goes well. Kidding. I've had lots of demos failed, don't worry. Don't sweat it. So you might expect typically to see a network diagram going to, right? But this is not associated with the physical hardware. It's a logical view of the data that's flowing.
Yeah.
And this is all running on fog computing.
That's right. The customers care about isn't the network, right? The connectivity is great. They need that. The security is very, very important. But the reality is the data and the business logic is really what we had to architect next.
Right. Now, we're not aiming to solve all of these problems, just some simple use cases that can get customers started. Okay, and that's what you can see in this tool. Essentially, it's very relatively easy for someone to understand. Oh, if this, then that, blah, blah, blah. Now, talk about the right-hand side.
The right-hand side is our actual output. So we've got, for this demo, we've got the sign and the gate. And then when the logic kicks in, it will actually set the outputs, either closing the gates or changing the messages on the signs.
Okay, so actuation, essentially.
Absolutely.
So, you might think about these inputs here as connectors in the code essentially would be a connector running in the IoT gateway, in our hardware. So we plugged in the serial port into the hardware and then mapped the serial data into this, which then translates it into our data flow, moves it out, and then on the other side we've connected, I assume, the actuators in through probably analog in this case, maybe
Correct.
digital sensors,
That's right.
into the router as well.
That's correct. That's
Okay.
correct. Yeah.
Okay, that's pretty cool. I think that's pretty simple. I think everyone probably understands that. Why don't you show them how it works? Let's show the
Absolutely.
audience. I want to see this.
So over here on the right, or on your left, we've got the default message, the fog during the day message. We've got a fog at night message, and of course, what we want to do is be able to update a default message. So what would you put on a sign right now if you wanted to drive down the road?
Enjoy the beautiful London weather. Don't text and drive. How about that?
Let's do don't
Probably-
text
it's probably
and
more.
drive. A little more
Should
relevant.
listen to that one more often. So when you do this, the rule is going to be pushed out as a default. It's going to go out from the cloud to the connected gateway router at the edge, the IoT edge, and then you're going to see it on the sign. Is that correct?
That's right. And so we're going to literally publish this logic all the way down to our IoT gateway, the 829 that's at the roadside. And so it'll be sitting there local, and it will update the signs. I'm just going to hit invoke,
Did it come up?
and our
There
sign
it is.
can
Okay,
change.
good. Well done. Step one. Okay, thank you. Yes. we like when real code works. now show some logic. So that's pretty simple.
Sure. So with our current setup, you saw the message board update as soon as we changed that default message. And now what we want to do is we want to add another element. We want to be able to change the gate. So again, this is something that instead of getting in and having to recode and compile and push this out as a program to the edge, what we're able to do is we're able to just drag and drop. We've got our change gate state, which is our output. We've got our current state that we have from a logic perspective, which says if it's day and it's clear. In the middle, it says open. And what we want to do is we want to connect these two together. So if this logic changes, we want to ensure that the gate is also updated. So we just simple drag and drop to say we're going to take the logic output from that orange block at the top in the middle, and we want to actuate the gate based on that. Right now, the gate is still open.
Okay. So let's see if it works.
Let's do it.
So that was it. You dragged and dropped.
That's right. As soon as we do that, that logic is pushed all the way out to the edge. So now it sits on the 829, and we're going to monitor in real time these values, these stream of data that's still coming back.
Let's prove it. Let's prove that it worked. I'm going to do this in 2 steps, easy and hard. So easy. Let's do easy. Easy would be if there's fog, the sign changes, basically.
Daytime.
So fight fog with fog. That's our ha-ha line in this presentation. We're going to insert some fog into the mix. So if I turn on this fog machine, we're going to start detecting the fog in real time. You'll see it, I think, on the lower left there, that 130.
That's right.
That's visibility. So let's try it. I'm going to turn on some fog. Okay.
Yeah, so our data stream is live. It's dropping down now. The threshold that we've chosen is about 40-foot visibility. As soon as we hit that, we'll cross the threshold, and we should see our sign change. Which
Okay, there it goes. It changed. Well done.
There we go.
Okay. Not too much applause. That was easy.
Yeah, that was easy.
The whole point of this whole thing is reliability, right? Scale, reliability, doesn't matter what happens. So what I want to do is make the demo a little harder. So I want to do the nighttime condition.
Okay.
But this time what I want to do, and this is going to take some audience participation, maybe we can have the CEO of Rockwell, Brett, come on up. Could you help us out here? Would you be okay with that? All right, come on down. So we know that connections are not always super reliable on the roadway. And internet connections are not always super reliable. So what I want to do is I want to prove that this whole thing works if we've had an outage. Okay. All right? So what I'd like you to do is cut the internet. So in here is an internet connection. There's a red wire in there. Just reach in on there and just cut it.
Not any red wire, not any red
wire. Go ahead, go ahead. Okay.
I'm showing this one.
You got it. Hey, look at that. Okay, just snip that.
Okay.
Okay, thank you very much. Your job is done. Everybody, thank you very much. So we've now cut the internet connection to this this device here and to this whole roadway. And so I think we can see it somewhere on here. That
we no longer are getting updates. Okay. So our streaming data is no longer being sent.
Right. So we've cut the internet. Thank you very much. And so now what I want to do is I want to prove that it's still foggy, but now we'll simulate a nighttime condition. And if that is if the rule has really been pushed down here and we don't have an internet connection, which we don't, actually I can take this out, there we go, just to prove, then the rule should still run, the logic should still execute, and everything should be fine, and the gate should come down. So if it's nighttime and it's foggy, the gate goes down. So let's try it. This is the hardest part of the demo, everybody. Whoa, my God, it went right away. Thank you.
There it is. It is a light sensor, right?
It's a light sensor.
Absolutely.
Very cool.
Yes.
That is fantastic. Thank you so much.
Thank you.
You know, you have done an incredible job. I know you've been very passionate about this project, and it's actually amazing to see how 25 years of pain could sort of be turned around in 1 year with a little bit of technology, but mostly with your sort of ingenuity and drive and passion. And so I think where it comes back to people, that's where you're making a difference for us. So thank you very much.
Thank you, Rowan.
Yeah, everybody.
Appreciate it.
Mark Nellinger, thank you so much. And thank you very much for our help on the cutting of the internet. That's very helpful. So that's one example, and it's a little bit of fun. Where's my clicker? I left my clicker. Guys in the back can do my clicking. So That's one example, and it's a little bit of fun about what we've been doing. The truth is that we have this technology in early field trials in a whole bunch of industries. We have it in mining, we have it in automotive, transportation, as you saw, oil and gas, and we're seeing great results. We're seeing great results, and that's one example, but there are many different ways you can configure this to actually see real tremendous results. And so that's what we've been doing. Now let's talk about availability. We've got to make sure this stuff's real and available. Click through to the next slide if you can. Someone gave it to me. Thank you guys. You saved me with my clicker. So let's talk about how you get started on this journey. You could start out with the hardware. It's pretty simple. Again, we've spent a lot of time over the last few years, almost quietly, updating all of our edge hardware. So whether it comes from the internet, the industrial Ethernet switches, or our industrialized routers, that was an IR 809, as you saw, all of these edge devices, including UCS, have been updated and now support the basic capabilities of fog computing. So that's the starting place. Choose your hardware from Cisco. The next step is, and that's available now, so you can buy that. It's doing real well. Our partners are selling it. The next step is security. Very, very important that you get security. So we announced that offer yesterday, and so buy our IoT Threat Defense offer, so add security to the mix, enabled by the hardware. So a lot of the security is built in. You're talking ICE and edge access control and so on. It's all built into the hardware. And then third, you buy our platform. And our platform is coming soon. We're going to announce the availability. It should be available in the next couple of months. And that's the IoT Operations Platform. And that's a cloud service, but it can also run on premises, and it's extended by all of our partners. And so that's the three-step plan to get started: buy our hardware, buy our security, and then ultimately move on and purchase this platform. So I want to kind of take it now back to the beginning of my presentation and wrap it up here. The outcome that we're looking for here is simple. It's taking a few steps forward for our customers. Let's go from 94% to 95%. I love big dreams in the IoT, I really do. But we got to make simple progress, and it's a big deal for our customers. You know, I think that we don't have to boil the ocean. We can make a few steps forward and make a huge, huge difference for our customers. So we look forward to working with all of you. Again, thank you very much for your time today. I'm really excited to be here and spend time with you. We've had a little bit of fun, and thank you so much for humoring us with the demo, a little bit impromptu. We had a great time sharing our progress with you, and look forward to working with all of you in the future. Thank you very, very, very much. Thank you.